Okay, we're
Hello, my future self.
we're running. Okay.
We're trying to run.
All right. So today, it's sort of in. I mean, technically, sometimes like the textbook that I'm gonna be giving you soon. That textbook starts with functions in the very first chapter, right? And I often wait for a while because who cares, right? You know, it's like in a way the function thing. It's not. It is and it isn't that important. It's you can do all the stuff we've been doing without knowing what I'm about to tell you. However, as we move forward, now is the time you have to understand it more. Almost everything you've been working with for the last 2 years have been functions. Okay? A function is merely, when I think of a function, I think of this. I think of a great big machine, right? All right, here's my big machine, right? And it has a little, an input spout, right? And then it has a little output spout, right? And this is my x. My x goes into this, and it comes out as a
X
y.
plus 2.
It comes out as a y, right? So if you think about it, if I gave you this equation, y is equal to x plus 2. Then this function machine, the machine itself is this, x plus 2. That's what it does. It goes y is equal to x plus 2. So it's going to take everything I put in, anytime I put an x into it, it's going to do this little process. And it's going to take that x, it's going to add 2, and it's going to spit out whatever it is. So if my x is a 4, it's going to spit out a 6. Does that make sense? If my x is a 10, it's going to spit out a 12. Right? It's going to add 2 to whatever number I put in. So it's what you've been doing all along. Y equals x plus 2. It's a function. Y equals x squared plus 2x minus 3 is a function. Right? All this stuff you've been working on is a function. 99% of what you've been doing is a function. Right? There's just a few cases where they're not functions in terms of what you've been working on so far. And we're going to talk about those. So a lot of times, though, in function notation, you will see these, instead of written like this, you'll see them written like this. F of x equals x plus 2. Right? It means the function of x. It doesn't mean f print times x. I know that's what you would think, right? Because it doesn't mean that. It doesn't mean you got to know what f is and you got to multiply it times x. That doesn't. It's just saying the function of x is equal to x plus 2. Right? Sometimes they don't use an f. They use a different number because, like, you'll say you have two functions. Here we have two functions. There's a function and there's a function. Sometimes they'll use a different letter. Like they might say h of x or g of x.
W of x.
Right? Or w of x, right? Equals x squared plus 2x minus 3. And so one of the nice things about using this notation, first of all, it's just the same thing as saying y. When you see f parenthesis x, it means y. When you see h parenthesis x, it means y. But it's telling you one little extra piece of information. It says that this equation is a function. And that right now you don't know what a function is, but you will soon, right? You can understand how you can tell what a function is. All right? And so the other nice thing about this notation is if I said f of x is equal to x plus 2, I could say, well, what is y when x is 7? So you could say this. You could write it like this. Find f of 7. In other words, whenever you see an x, you replace it with 7. So 7 plus 2 is 9. So it would be 9. Does that make sense? So you'll see that. It's not a big deal. It's really a piece of cake, right? It's not anything that's going to throw you off balance. But you will have to know how to determine whether something is a function. So first of all, we're going to talk about this. Functions have properties, certain properties about them, okay? They have domains, they have a set of domains, and they have a set of ranges. Now your domains your domains, the term domain stands for this. The set of all possible x's. Right? Does that make sense? So think about it. If I did a t-chart for this one, for this, y equals x plus 2, and I did a t-chart, right? Let's see, I could do, is there anything I can't make x? I don't know, like let's just try it. 0, 1, and 2, so that would be 0 plus 2 is 2, 1 plus 2 is 3, 2 plus 2 is 4. So if I were going to graph this, got to make sure I have room on them. Whether this can be seen. Where am I? I can't even see that. Probably because I didn't drop it. This is getting worse and worse. I'm switching colors.
This color.
Can you see that? This is not so good either, but that's okay. But if I were going to plot this, I could use this t-chart, or I could actually use slope-intercept method, right? 1 over 1, doesn't matter, but I got to plot it. So up 2, I'm going to use slope-intercept. 1, 2, put a dot, and then up 1 over 1, put a dot, and I draw my line. And what do I put at the end of my lines?
Arrows.
Arrows.
Because it goes on forever.
So what are the possible x's? As I move further and further to the right, where does it stop?
It doesn't.
It doesn't ever stop, right? What about as I move further to the right, to the left?
It doesn't.
It never stops. They go on forever. So there's no exception to the x's, right? Meaning x would be the domain of this equation
So that could be anything.
would be all real numbers, right? Because there actually are in algebra there are also unreal numbers. There are numbers called imaginary numbers.
Oh,
Okay?
no. Like I.
Like the square root of -1, right? That's an unreal number. It's an imaginary number because there isn't such a thing. But mathematicians and scientists have found that it's useful to have a way to go beyond that somehow. So, but we're talking in the real category, right? So it's all real numbers. It makes sense, right? X could be anything. It could be 0. It could be 1,000,000. It could be infinity. It could be infinity this way. It could go on forever.
Negative
So
infinity.
my domain for this, there's nothing that X cannot be, right?
Is that always true?
There's nothing X cannot be. For a straight line, great question. For a straight line, that is always true. So the domain for straight lines, for all straight lines, the domain is all real numbers. Whoops. It could go on forever, right? Okay, now we're going to go to range. Range. The range is the set of, what do you think? Of all possible, what?
Lines?
Yes. Y's. Okay? All right, so now, I'll give you a second. So, let's look at this graph again. Straight line, right? Is there any place as I go up that line stops?
No.
Do you guys agree with me? It goes on forever, right? So my y's go on forever upwards. What about going downwards?
Yeah.
This line keeps going, right? There's never a place where the y's stop. The range is also all real numbers. For straight lines, as long as they go on forever, the domain and range are both all real numbers.
What if they're lines that are perpendicular to the x or y axis? So then,
Very good question. That's a really good question.
so then like the y's would not go on that way forever, because like if it was perpendicular to the x-axis, then it would go.
You're right.
Yes.
Right. So exactly. So she's saying, okay, well, what if you had a horizontal line What is the set of domain? What's the domain? The set of all possible x's. Would you agree with me that my x's go on forever in this direction? My x's go on ever that way. So my domain for this one, so the way you write this equation, just so you know, is 1, 2, 3. Let's say that's at -3. This is y equals -3. That's what that equation is. Y is equal to -3. There's no x in it, right? There's no x in the equation. But I can, so if x were 0, what's y? -3. It says it's always -3, right? If x is 10, what's y? -3. It's always -3. It doesn't care what x is, right? Doesn't mean you don't have an x. You just don't have it in the equation. It doesn't care what x is. Y, no matter what x is, y is always -3. So my domain can be anything, right? My x can go all the way that way or all the way this way forever. So my domain would be all real numbers. Sometimes they write all real numbers as a big capital R like that. See that? That stands for all real numbers. That's my domain. But my range is what? Y is equal to what? -3. That's it. My range can't be anything else. Does that make sense? Because I can't be up here because my line's down here. It's always going in a horizontal direction, right? I only have one range. My y has to be -3. That's it. Does that make sense? Okay? And we're going to talk about the vertical one later. Is that okay? Even though that was a great question. It's going to make more sense soon, right? You're just bear with me for just a little longer. Let me think. Where was I going with all this, though? There's one other key element of something being a function. Okay? Sorry, mind your way. There's one other key element. And this is actually the keyest of all elements. This is the most important element in terms of defining what a function is. And it says for every x. Okay, this is really important. That does not look like a star. That looks like a star. This is really important. For every x, comma, there can be / must be only one value of x, of y. Only one value of y. So write that down and we'll talk about it. For every x, there can be / must be only one value of y. Let's look at a straight line, because we know all straight lines are functions, right? At least, well, actually we don't know that exactly. We know that a horizontal line is a function, and we know that a diagonal line is a function. We haven't talked about vertical lines yet, right? But look at this. If I go to here, at x is 1, how many times do how many values of y are there? There's only one, right? You with me? I don't have any other y besides the one there, right? Yes? Am I losing you guys?
Yeah.
That's it. So, is there any place on this line? The way you find out is called a vertical line test. So if you have a graph, if you have a graph, you use the vertical line test. And the vertical line test says this. You take a vertical line and you hold it vertically and you move it across. So if we're talking about this line right here, I move it across like this. if that vertical line is touching the line in more than one place at the same time, it's not a function. All right? But do you agree with me? It's only touching in one place at any given time.
Yeah.
Right here, it's touching it here. It's touching it here. Here, 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 here. Only one place.
So a parabola can't be like it would.
So that's a great question. So can I erase the function box? Okay.
No, you can't erase the function box.
All right. I'm not liking any of my markers. It's driving me crazy. Ah, that's good. Okay, so watch this. Let's look at a parabola. A parabola, right? A parabola, it goes on forever. You agree with me with that?
Yeah.
A parabola goes on forever. And do you also know that a parabola is always getting wider?
Yeah.
I mean, it's getting
So
wider
it goes
slowly,
like-
right? Really slowly. It's not going like this. It could be. It could be a very wide parabola. But a lot of times they're getting wider very, very slowly. But they're always getting wider, right? And watch this. Vertical line test. It's only hitting it in one spot, right? One spot at any given time. Only one spot. Here, 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 here.
So a
here,
parabola is still a
here.
function.
So a parabola is a function. So can anybody suggest a shape that would not be a function?
A circle.
Hyperbola. No. Probably.
A circle.
Okay, let's try a circle. Let's try a circle. Here we go. We got a circle. All right, here we go. All right, come along here. Ah, it's only hitting once, right there. See that? Ta-da, ta-da. Oh wait, if I go a little further.
Uh-oh.
It's hitting.
Uh-oh. For this x right here, it's hitting here and here. I have two values. They're totally different. Totally different for the same x. It is not a function. It is still a circle, but it's not a
Stupid
function.
circle.
And it is called a relation. Everything is a relation, but only functions. In order for it to be a function, it has to be a shape that never curves back on itself. Does that make sense? Right? It can't be a square. It can't be a box. It can't be, ironically, a vertical line. Because think about
Oh
it.
yeah, because
Right?
it
'Cause
would
at
be
this
like all
X,
the points at the
Look,
same
how
time.
many y's do you have for this x?
A lot.
All of them.
As
Infinite number, right?
numbers of
It's not a
lines.
function.
Well, it probably still is, though. You're only hitting, like, infinite points, so I think you could...
But it's not a function.
No, but well, yeah,
You
'cause
can't
y
have
has
more
to
than
be
one
infinite.
value.
It's
Right?
only infinite. That's not that big. I think we can just let that slide.
Right. Yeah. I see your point. You may be excused. But does that make sense? You getting it? You getting the idea of a function? So if you had a parabola that was sideways, would that be a function?
No.
No. That's why we're not spending a lot of time on those, right? Because as we move into calculus, most of calculus is talking about
We're doing
functions.
calculus this year?
No, as you move into, sorry, but a lot of higher level math, a lot of stuff you're about to you're moving towards, will be dealing with functions, and so you will be dealing more and more with these. We are actually going to be talking about these very soon. Actually, next Monday, a week from Monday. But we're only going to be talking about half of them because we want them to be a function.
It's a lie.
We're going to talk about those, which is the square root of x, exactly. We're going to talk about those
over
coming
there.
up when we get back. Yeah, right there,
Oh, you guys
So-
talk about why.
right? We're going to be talking about those because they're very much related to quadratics. They're just a little different, and we just have to look at
We
it.
should do the y equals x cubed. That's weird.
So, so now what I want, yes, question.
So what's the? Could you go into more depth on what a relation is?
A relation is
Is
any group,
anything
any
that's
group
not a
of
function.
points, any group of set of points, right, that have an x and a y. Doesn't matter how. It doesn't matter how they're related. It could be, right? It doesn't matter, right? But they are related somehow, right? I don't know how they're related, but they're related. This one's related to this one, and because it's in the same quadrant. This one's related to this one because it's in the opposite quadrant. This one's related to this one because this one's related to this one because it's in the next to the quadrant. Different. What I mean? They're all related, right? So relations are anything. Any combinations of points would be a relation.
Wait, so functions can be relations, but relations can be functions.
Correct.
Okay.
Does that make sense? Well,
Well,
functions.
Like, if it can be a function and a relation, but but sometimes it can't be like.
Everything is a relation. Everything is a relation.
Yeah.
But only some things are functions. Does that make sense? Functions are always relations.
It's like all functions
relations
can be
are not always
relations, but not-
functions.
Yeah, that's what I meant.
Because relations don't have that rule that says for every x there can only be one y. This is a relation. It is not a function. This is a relation and a function. This is a relation and a function, right?
So functions are always relations,
Yes.
but relations aren't
Yes.
always
Does
functions.
that make sense? You guys get that? All right, but that's right. Functions are always relations, right? It's like boys are always humans, right?
Girls
Are you sure?
Are always
Right now.
humans, right?
I don't know about that.
But
Wait, no, that doesn't work.
but boys are not always. I mean, humans are not always boys, right?
Oh, I get it.
See what I mean?
Yes.
Boys are always humans, but humans are not always boys. So relations, everything's a relation, but it's not always a function. But all functions are relations. See what I'm saying? That makes sense? Right? Or the relation is the bigger thing, right? It's the bigger picture. The function is we're narrowing it now. Only some of the relations are functions, right? So that's what we've been talking about. So now I think we're pretty much done. Let me show you. Now the big last question, I'm going to actually erase this stuff. The big last question is how can you tell if something is a function? All right, the first thing is the vertical
Just
line
get the
test.
line and
The vertical line test is easy, right? Isn't that easy? It's a piece of cake, right?
cake.
But what if you don't have a line?
But what if you don't have a line? What if you have coordinates?
Oh.
What if you have a T-chart?
Well,
Then
then
just
you
graph
make
it.
sure that
Graph
none of the y's equal each other.
You just
So-
graph it and then do the vertical.
Sometimes, let me get rid of this thing.
Because the coordinates tell you the y's. So if two y's are the same, then you know.
So
gee,
watch.
this is
If
not-
I had, sometimes you have a T-chart like this, right? Let's say I have 0, 1, 2, 3, 4, and I have 8, 7, 3, 9, 11.
Just graph it. And then do the
Is this a function?
Yes.
Yeah.
How do you know?
Because the y's are different. For each x, there's a different y.
Okay. Do I have any repeats on my x's? No. All right. This is a function. I don't know what the function is,
Wait.
but it is a function.
Gary,
What?
well, if you think about it with parabolas, they're like symmetrical. So, is it because the x doesn't repeat?
Yeah, that's a really key point. So watch this. What is this a function? 0, 1, 2, 3, 4, 5, 2, 6, 2, 1,
No.
2,
No.
2. Is that a function?
No.
No.
Think about the rule though. It says for every x, for every unique x,
It is.
Oh, wait,
there
no,
can
it is.
only be one value of y.
Oh, that would only not be a function if there are like say like two 2's in there and each one has a different.
It's only the
Okay.
x's. If
That makes
x's
sense.
are repeated,
It is
then
not-
they would have two different types of y, two values for y. That would not be a function,
So if
right?
x's are
But as long as there's no repeats in the domain, in the x's, it is a function, period. It's fine if they're all the same. I could do this. I could say 0, 1, 2, 3, 4, and I could do 4, 4, 4, 4, 4. That's okay. That's going to be a straight line, horizontal straight line, right? 0, 4, 1, 4, 2, 4, 3, 4. It's going to be a horizontal line.
Oh, so
Right.
if any of the x's repeat, then it's not.
But if the x's repeat, this is not a function. 0, 1, 2, 3, 4, 2. Immediately, as soon as I put a 2 there, and there's a 2 here, and notice I'll have 6, 8, 10, 11, 13, 12.
graph it.
Look, 2, remember I've got my function box, right? And in goes a 2. A 2 goes in, and you've got to have only one value for that 2 spitting out, right? Y is equal to x plus 2, right? It's got to be only 4. Well, okay, so this is 8. X plus 6, right? We'll say that. So, wait a minute, where am I? 10. X plus 8. Sorry, I'm looking at the wrong thing. Right? So there's my function. I plug in a 2, and it spits out a 10. Right? Does that make sense?
Oh my god.
But look,
That's crazy.
but I have another 2 here. I plug in a 2, and suddenly it spits out a 12.
That doesn't make
What if it
It
spit out
doesn't make
another
sense.
10?
It's not a function.
Gary, what if
It's
it spit
still
out
a
another
relation
10?
because they're related somehow. You know, they're on the same planet. Right? They're on the same graph. They're related somehow. But they're not functions. They're not related to this function. Right? You know what I'm saying? So
it's not just
that's how
a
you check. You always look at the x's. If the x's are repeated immediately, it is not a
But
function.
what if that was a 10? What if that y? What if that 12 was a 10? And
If
it
that was a
repeated?
10, then that would be okay. But that's never how they do them when they try to trick you. Like when you take an SAT test or pre-SAT test or ACT
That's not
test,
gonna happen.
they're always going to repeat these, and there'll be different values of y, and you're going to say, no, it is not a function. This is a function. There's no repeats of the x's. No repeats of the x's. No repeats of the x's. Oops, there's 2 2's, different y values, not a function. Right?
But so if
No.
if there's 2 repeating x's and the y for both is the same, then it's a function.
It is technically a function. Right?
So like if that one with all the 4s, if it was like the x's were all 2s and the y's were all 4s, it would still be a function.
No, because
Yeah,
you have
because it
x's.
could be like-
X's are 2. You've got
Yeah,
more than
but
one
they
2.
all equal the same.
Oh, I see. You've got all.
If it was all the y's were all
Well, it could
4s
be
and the
like-
x's were all 2s,
Well, the
Then
equation would be
technically
like.
it would be a function because
No, well,
but that
if
wouldn't
they
happen.
Were if the y's were all the same, then it could technically be an equation like x times be like 0x plus 4, and you get a 4 for all of them.
sometimes you'll see it like this. This is a real common kind of question you'll see on an SAT or an ACT test.
Oh, that thing.
They will call this your input, and this your output. Just like a function, right? A function machine. You input the x, right? The x is the input, right? The x is the input. The y is your output on your machine, right? You with me?
Yes.
All right. And so let's say we had 1, 2, 3, 4, and they had 6, 7, 8, 9, and they drew lines like this.
Oh.
No.
Is that a function?
Yes.
All you have to look at is the x's. Are there any repeats?
No.
None. It's a function. Right? All right, let me redraw my lines now. Is this a function?
Gary, it's a function.
Yes. Yes. No.
No.
Wait, no, it's not.
Why?
No.
Because the 3 has like 2 values. To
Right,
the
you
y.
can't have 2 values, 2 different values of y for one input. The x, right? That's like saying 3, 7, and 3, 9, right? It's like repeating, right? You can't have
And the 8's all
2 things
one.
going from the x. What about this, though? Is that okay to have 2 things going from the y to the 2 and the 3?
Yeah.
That's
if
okay.
If the 3 wasn't connected to either the 9 or the 7, it would
Yeah.
be fine.
All right, so that's basically it. Sometimes you'll see them written like this. So this is your x and this is your y, or they might say input and output, right? And then you've got, 2, 4, 6,
9.
2, and then
No.
this
No,
is
it is not
9, 1, 7, 6.
No.
It's no, because the x's have 2 of this. There's repeats, and they have different values for y. It's not a function, right? Clear?
Yes.
All right. Last piece, the very, very last piece. That's awesome. So now you understand functions.
Yep.
You've been dealing with them all along. You just didn't realize it, right? You've been dealing with. You put the x in. If x equals something, y is equal to something. Whenever you did a t-chart, you were doing a function, right?
Can we do these on the board? Like, can you give us one,
Some problem?
and then like we have to see
Come-
if it's a function or not?
Yeah.
We don't really need boards for that. Wait, did you say you want?
I was thinking of doing that with the whiteboards.
Gary,
wanna
is
do
there
that?
any way,
Yeah, I think that's what you just
like,
asked.
just to make sure our
Yeah,
grade
we
is
don't need
safe?
the boards though, do we? Don't we just see if it's yes or
All right.
no?
So the
You
last
just
thing,
write yes or no.
the last thing, and this last part is the part that you have to know more than the function part, right? I mean, that I consider way more important, and it's understanding domain and range, and stating what is the domain and what is the range of every shape, of every graph, right? So if I give you a graph, we figured this one. The domain is all the x's and it's all real numbers, right? The range was all real numbers. It never ends, right? They keep getting bigger that way and they keep getting bigger that way. All right. So here's let's look at some. And I'm going to show you how you write them. Okay. This goes on forever, right? What is my domain? So for this one, my domain, we'll do it together first. Would you agree with me that this is always moving wider this way?
Yes.
So even if I go in an infinite number of spaces that way, eventually, and then I went up, eventually I'd find the other y, right? I mean,
Yeah.
the y to that point. So, and it goes forever this way, right?
Yeah.
So the domain is all real numbers, right?
Yes.
All real numbers. All real numbers. Or I could say this, right? The capital
Squirrely R.
squirrely R means all real numbers. All right. My range, though, what is my range? What is my range? Can it be below 0? What's my range on this? Is there any
It's like-
part of the
it's like-
parabola below 0?
No.
No, so
No.
it's like
Is it
above
2?
2. It's like 2.
Yeah, how would you say it?
Range is
Plus
2.
Y,
Y.
equals
X plus 2?
2.
Equal, more,
What?
greater than or equal to 2.
There you go.
Oh.
Think about it. Can it equal 2?
Yes.
Yeah, because it starts at 2. Can it go below 2?
No.
No, because there's no parabola below 2. But is there a parabola above 2?
Yes.
And does it go on forever? Forever?
Yes.
Yeah, it's going up forever from 2, right? So my range is x must be greater than, but also equal to 2. Does that make sense? You get that?
Yes.
It's pretty straightforward once you get it.
Yeah.
It's really not hard, but you have to understand it because you will be asked these questions a lot. All right? So how about this? Okay. What is my domain?
X is less than or equal to 4.
Okay, but what's my domain?
All real numbers.
Okay, all real numbers, right? My range, go ahead. What did you say, Nathan?
4 X.
Well, remember, range is y.
range
Did I?
is Y.
Oh, sorry, I made a mistake there. That's a y. Sorry
Y
about that. Right?
is less than or equal to 4.
Y is less than or equal to 4. Okay, fabulous. Right? Is it making sense?
Yeah.
You start to see how to figure that out?
Yeah.
Okay, it's not hard. All right, what about this one? You haven't done this yet, but what if I gave you this?
Y equals square root of x.
What is my domain? This is, let's say this is 1, 2, 3, 4, so this is 2. And then, whatever, this is y and this is x. Yeah, that is y equals, well, it's y equals the square root of x minus something. Minus 2, actually. But
Okay, does
Don't
that, we didn't learn this yet. So
you haven't learned that yet. But what is the
This is
domain?
like
To
keep-
know the domain and the range, all you have to do is look at the graph.
Yes, but do we know if that is supposed to continue on, or does it
This
like...
continues on in this direction, but it does not here.
Okay.
So it's solid stops there.
So would it be greater than or equal to 0?
So domain first. Domain
R.
first. That's all the possible x's. Can x be 0?
Yes.
Yeah,
No.
Can x be negative?
No. Okay, x
It's
can be...
2.
X can be...
It can be 2. Can it be more than 2?
Yes.
Yes.
X is greater than or equal to 2.
Right. Beautiful, right? And then what about the range? Range. We, just like a parabola, this is sideways, right?
It's
But
like,
it's always getting bigger, right?
yeah, so
It's always
it's
going
always-
higher, right? Always going higher.
Wait,
Wait,
Do you have the other way around? Isn't the
it's
domain
greater
supposed to
than
be?
or equal to 0, right?
Right, it starts at 0, right?
Wait,
The
but
y,
Gary, doesn't the domain switch with the range here though, like all the other ones?
Because all other ones,
This doesn't
domain
X,
is
like
R.
range equals y. Range is y is greater than or equal to 2.
The
instead of
domain is
X.
usually all real numbers, right?
Like,
well, wait, but remember, range is
No,
this way,
because the domain is
Okay.
the X.
right?
So it's like-
Domain is this way.
Oh.
So the domain is all the possible x's you can't have here because it's not there. You can start at 2 and get
okay,
bigger.
so depending on like whether or not it's
Word-
a parabola or like a word parabola or a sideways parabola, it'll be like either a domain or a range.
Yeah, for any kind of thing, there's domain and range. So where does it start? Can the range start at negative something?
No.
No, because it starts here at 0. This is 0, 2 comma 0. My y is 0, right? So range must be bigger than 0. Does it include 0? It's a solid dot. If I had done this, it would not be. I would have to say greater than 0, right? But it's not. It's a solid dot. So range, which is y, is greater than or equal to 0. Right? Does that make sense?
Yes.
You getting it? Fist to 5? Yes or no?
Wait,
Just so I know. All right. I mean, we'll practice it more, but this was a key part that I hadn't explained that I had to be done with quadratics, right? Now that we have done it, we at least have seen it. We're going to talk more and more about domain and range as we move into the other stuff, because you just have to understand it and get really comfortable with it. It's really, really easy. You know, it's so visual. You can see it immediately, you know, what the answer is, right? If it was over here, what if I had this point right here? And that point was, the vertex was negative 8, comma,
but it's above the y-axis. That makes no sense.
7, right? So what?
Oh, yes.
So that's my vertex, right? Here's my x axis. What is the domain for this one?
Let me see. Okay,
Less
so
than
it's,
or equal
Remember,
to
this
8.
is my x and this is my y.
Is it less than or equal to 8 or?
okay, so the y is all real numbers, I think.
No, the
Yes.
X is all real.
No, what?
So
Oh, yeah,
what?
that's,
Say
sorry,
it
that's
again.
the x. That is the x. Yes. So yeah, the x is all real numbers,
So domain is all real numbers, right?
and then
X is
the range
all real numbers.
is less than or equal to -8.
Y is less than or equal to
Oh wait,
negative 8.
-7. Wait,
Or, yeah,
negative
no,
7. No,
oh.
but you said is that the point or is
Oh,
that
I'm sorry.
Yes,
Ne-
that's
to
negative.
7. Sorry.
to 7?
Sorry.
To 7.
oh, okay.
Right? Does it make sense?
No.
Okay. This is my x. I moved over 8 this way, and I went up 7 this way. All parabolas get bigger and bigger going side. I mean, they always are getting wider, right? Does it make sense? So, all my domain are all my possible x's. There's no end to my possible x's. The parabola forever is getting bigger. So my domain is always getting bigger. So the domain can be any real number. It can be positive infinity, it could be negative infinity, right? Because there's always going to be a graph getting bigger and bigger, you know, going further out. There's always going to be a y portion of my graph, no matter what my x is. However, my y, my range, says my y cannot be above 7, right? Does that make sense? 7 is the highest point. Remember in vertex? Remember when I asked you what's the maximum height of the ball that you threw? That means you're finding the vertex, right? And you're finding in particular the y. The y tells you the height. The x tells you the time it took to get to that height, right? That would tell me, well, in this case, yeah, it's not a good example here because you don't throw the ball negative, right? I mean, but anyways, you got the idea. But so the y though is your height. The y is your height, right? So the ball can never be higher than 7, right? So my range can never be above 7, but it can be equal to 7. It can be below 7. So all my possible y's start at 7, and they go down from there. They're all
Wait,
lessons.
what about like
So you missed a lot of this, but go ahead, ask your question.
since it has I know that it has like infinite points, but what about like in the middle part where it's like not touching?
Yeah, but it doesn't have to be touching anything. It's just there,
Oh.
right? Like there's a y here and here and here and here, here. There's an x here and here, right?
Yeah.
Right? But there isn't a y here.
Yeah, but what about like inside of the parabola?
Oh, you're saying inside the parabola. That's not going to affect the domain and the range because it's right. Because like, let's say if x were here, well, see, domain is really talking about. Am I right? Just talking about the outer edge, right? That's a great question. I haven't ever thought of that question before. But my concept of it is that it would have to only include the outer edge because otherwise you'd be destroying your concept of what a function is. A function says for every x there can only be one y. And if I included all of this area in here, right? Right? Then I would have for this x right here, I would have this y and this y and this y and this y, and it wouldn't be a function anymore, right? Different values of y. So when you're talking, at least, can you? But you could say we'll confer, and I'll answer that question in a week from Monday. Okay. All right. So that's it for the lecture. So I'm going to turn this thing off. That was a long lecture. Sorry.